Hey, ladies and gentlemen, I'm doing a run through on the lesson that we are going to be doing tomorrow, um, and this is sight unseen. So let's see how it goes. Energy changes in chemical reactions. Okay, so let's take a look. Alexander, Riccardo, as always. Okay. All right, in the previous lesson, you compared a series of reactions between test liquids and known substances with a set of reactions using the test liquids with an unknown substance. You use the results to identify the unknown substance. In this lesson, you'll investigate how chemical reactions can result in a higher temperature by releasing energy, exothermic, or result in a lower temperature by absorbing energy, endothermic. You have already seen exothermic and endothermic processes when dissolving certain substances. In this lesson, you'll see similar concepts to understand how chemical reactions can be exothermic and endothermic. So basically, how chemical reactions can can get hot and get cold, right? Uh, let's see. So we're going to measure the temperature when baking soda and vinegar react. All right.
There is a small amount of vinegar at the bottom of this cup. There's a thermometer recording the temperature of the vinegar, which is currently about 21.5 degrees Celsius. Vinegar is one of the reactants. Now we'll add the second reactant, which is baking soda. The baking soda and vinegar react. A gas is produced and forms bubbles. Look at what happens to the temperature during the reaction. The temperature is decreasing. It started between 21 and 22 degrees Celsius and drops down to about 18 degrees Celsius or even further. Let's watch that again and talk about this reaction. When the temperature of a chemical reaction decreases, the reaction is called endothermic. The first part of the word endo means in or into, and thermic has to do with heat or energy. So an endothermic reaction means that more energy goes into making the reaction happen than is released by the reaction. This leaves the reaction mixture at a lower temperature.
Okay. So what did you notice about the temperature when the baking soda was added to the vinegar? It dropped, right? So it went from, how far did it drop? Let's take a look. It went from 21 to 18, right?
Temperature.
Hold on a sec. It went from 21 to, was it 25? No, not 25. 25. I hate this part. All right, let's see. Starts at 21 and ended at 18. All right. So went from, it decreased from 21 to 18. All right. Was this endothermic or exothermic? This is endothermic, right? So let's see. It went from 21 to 18 and it was endothermic. Got it. All right. And now we're going to do the opposite. When measuring the temperature when calcium chloride and baking soda solution react, notice that it starts at about 22. All right. Let's take a look.
In this cup, we have a solution of baking soda dissolved in water. The temperature is about 22 degrees Celsius. We will add calcium chloride solid to the baking soda solution, and the two react with each other and produce products. Along with these products, you'll notice that the temperature is increasing. The temperature started at 22 degrees Celsius and is rising to 25 degrees Celsius. Let's watch again and discuss this reaction. When the reaction temperature increases, we call it an exothermic reaction. The first part of the word exo means out or out of, and thermic has to do with heat or heat energy. So an exothermic reaction means that more energy goes out or is released by the reaction than goes into it. This leaves the reaction mixture at a higher temperature.
All right. Cool. So what did you notice about the temperature when calcium chloride was added to baking soda solution? It increased from 22 to 25. Yeah. and this is considered an exothermic because it gave off heat. Right. So that was 22 to 25 and exothermic, rocking and rolling. All right. To get an idea about why a reaction might cause a change in temperature, let's look back at a reaction we've seen before. The reaction between methane and oxygen is a combustion reaction that releases a lot of energy, resulting in a large increase in temperature. So let's take a look at that.
Let's look back at a reaction we've seen before. The reaction between methane, which is the fuel in a stove, and oxygen is a combustion reaction that releases a lot of energy, resulting in a large increase of temperature. When methane reacts with oxygen, energy is used to break apart the existing bonds between the atoms in the reactants. The atoms of the reactants then rearrange and form new molecules to make products. The forming of products releases a lot of energy. In this exothermic reaction, more energy is released, and so the arrows coming out of the products are larger than the arrows going into the reactants. The energy that is released becomes heat, and the temperature increases.
Mm-hmm.
Let's watch this again. Combustion is an exothermic reaction, so more energy will be released than goes in. You can see a small amount of energy goes in to break the bonds in the reactants. The atoms rearrange and form the molecules of the products and release a larger amount of energy. The energy that is released increases the temperature in this exothermic reaction.
Okay. All right. The reaction between methane and oxygen releases a lot of energy. What does this do to the temperature? It increases it. Since more energy is released when the bond is in the products are formed, then it is used to break the bonds of the reactants. The combustion of methane is an example of an exothermic reaction. Right? So the combination it says a lot of things. It says it increases, and it's an exothermic reaction. Awesome. Okay. All right. Now we're going to take a look at endothermic and exothermic reactions.
A chemical reaction involves the breaking of bonds in the reactants and the making of bonds in the products. We will look at two types of chemical reactions and look at how the energy is different between the two. First, an endothermic reaction. Energy arrows going into the reactants show the energy required to break apart the bonds between atoms in the reactants. The atoms rearrange to form products and new bonds form, releasing energy. In an endothermic reaction, less energy is released when products form than was required to break apart the bonds in the reactants to begin with. Let's watch it again. A certain amount of energy is required to break apart the initial bonds in the reactants. When bonds form in the products, energy is released. Because this is endothermic, more energy goes in to break the bonds than comes out when new bonds are formed. More energy is going into the reaction than is being released, and this energy is coming from the molecules in the surroundings, so the surroundings cool off and the temperature decreases. Endothermic reactions have decreasing temperatures.
That's right.
Now let's look at an exothermic reaction.
Sorry.
Energy is required to break apart the bonds in the reactants, as in all chemical reactions. You will see energy arrows showing this energy. The atoms of the reactants rearrange and form products, and energy is released as these new bonds form. In an exothermic reaction, the overall energy balance is energy exiting. More energy comes out of the products than goes in to breaking the bonds in the reactants. Let's watch it again. For an exothermic reaction, energy goes in to break bonds in reactants. Energy exits when products form, and a greater amount of energy exits than goes in. And so this is an exothermic reaction, and it heats up.
Okay. In an endothermic exothermic reaction, what do the arrows mean that go into the reactants? The energy. What do the arrows mean that come out? Come out of that go in. Energy needed for the reaction, and energy released from the reaction. The reaction is endothermic. What is true about the amount of energy required to break the bonds of the reactants compared to the energy released when the products are formed? The energy to break the bonds is less than what is released? No, it's greater than what is released. Yes. All right. If it's exothermic, what is true about that? Okay, so the energy is less than the energy that is released. Yes. Okay. So let's take a look. The arrows represent the energy it takes to break the bonds. All right, going into it. Energy released. Okay. If endothermic required to break the bonds is greater, and then less. Excellent. Boom. Got them. All right. Look at picture of the reaction between calcium chloride and baking soda solution. Calcium chloride 2 to sodium hydrogen carbon oxygen 3. All right. Calcium carbonate, 2 sodium chloride, 1 water, 1 carbon dioxide. Since this was an exothermic reaction, what do you know about the amount of energy required to break the bonds of the reactants compared to the amount of energy required to form the products? It's less, uh, less, uh, uh, less to break them, break the bonds than the amount required to form the product because it gives off a lot of energy. If you're going to use arrows where the bigger in the arrows, the biggers would be in the smallers would be in the reactants and the biggers would be in the product. All right, see if I got that right. Since this is exothermic, more energy is released. More something smaller will go into the thing, and a bigger one will come out of it. Yes, I got it. Sweet. All right. Look at the picture of the reaction between baking soda and vinegar. Acetic acid and sodium bicarbonate make up nacho, sodium acetate, water, and carbon dioxide. This is an endothermic reaction, means that a lot of energy goes to take it in, so it's colder, and a little bit comes out. All right, since this is endothermic, what do you know about the amount of energy required to break the bonds of the reactants compared to it? So there's a lot of energy to get in to break the bonds, and coming little coming off to form the product. All right. And if you're using energy arrows, you're going to have bigger ones on the reactants and then smaller ones on the product. All right. That's what it's going to say. It's bigger, larger over here, smaller over there. Good. Very good. All right. Watch the 2 videos of exothermic reactions. All right, let's take a look.
The demonstration shown in this video is very dangerous. Do not attempt to perform this demonstration. This is the thermite reaction. In the flower pot, we have iron oxide, also known as rust, aluminum, and a catalyst. These will react to produce elemental iron and aluminum oxide. So much heat is produced in this reaction that the iron becomes a liquid. The heat is so intense that the molten iron could be used to weld railroad tracks together. This reaction is extremely exothermic.
There's a thermite bombs. And this one is the white phosphorus. This is a flashbang.
The demonstration shown in this video is very dangerous. Do not attempt this demonstration at home. Here we have white phosphorus, which is dissolved in a solvent and in the dropper bottle. In a moment, you'll see what happens when the white phosphorus reacts with oxygen in the air in an incredibly exothermic reaction.
An element dissolved in carbon disulfide is taken into a medicine dropper and used to write on a piece of filter paper. As the solvent carbon disulfide evaporates away, the element begins to react with oxygen from the air in a spontaneous exothermic combustion reaction.
Flash
This
bang!
exothermic reaction gives off light and heat.
All right, how can you tell these threads are exothermic? They gave off light and heat. All right, both are because of light and heat. Yay! And that's it. All right, and uh, I would do this part, but I'm more focused on this part. I feel great about this one. Exothermic means that it gives off a lot of heat and little energy to do the reaction, but it gives off a lot in the product. And then endothermic means that it takes a lot of energy to do it, but it gives off a little bit, so it gets kind of colder. So I really like this one. It was simple, it was easy, and I hope you guys have a good show of it as well. And then other than that, it's pretty good. All right. So this is